We got the ratio and proportion practice test. Here we go. We're gonna be focusing on, can we do that right there? Can we represent a relationship, a proportional relationship, in 4 ways using words, ratio tables, graphs, and equations? Let's start with the tables. So what we're gonna do, or what all tables are, by the way, if you're like just here for the answers, this is gonna be a long video for you because I'm going to be walking through almost every problem that I can. In fact, I will let you know I did 1 and 2 and their graphs and all 3 of those in class. So you might, if you don't need to, you could skip some of those because, well, I've already done them with you. So, but if you are here because you're like, I just need some help, cool, let's do it. When it comes to these, what's happening is 4 is being multiplied by some number and it equals 10. Now you might think, hey, listen, I'm just gonna try and multiply my little heart out and I will eventually figure out what number goes in there. If that's what you wanna do, go for it. But my recommendation is to divide. And if you're like, but how can I take this and turn it into division? Well, I'm glad you asked, because what's happening is this is not just 4 times a blank, it's 4 times a variable, so to speak. So how we can figure this out is division, because that's how you could solve a problem like this, okay? Is it's 10 divided by 4, and if you're like, okay, that seems kind of familiar, okay, cool, I'm glad it does, because you get 2.5. And if you want me to show you how to do long division, okay, I'll do that over here. 4 into 10. How many times does 4 go into 10? Twice. So that would be 2 times 4 is 8. And now we're going to subtract to get 2. There's an invisible decimal here as well as infinite zeros. We're not going to need infinite zeros though. We're just going to need this 1. How many times does 4 go into 20? 5 times. So there's 20, and now it's 0. And when you get 0, you're very happy because you have successfully divided that number, and it's over, okay? So the rate is 2.5. That's important because that helps us kind of give the rest of the table. It actually helps us do really everything. It helps us graph, it helps us with the equation, and we can complete the table. Now the words part, I mean, here's the thing. We could do this without the rest of it. Technically, you could do half of the tables without the rate. And if you're like, what do you mean I could do half the tables? Here's what I will show you. You could fill in this table without the rate. In fact, just watch this. If I multiply both of those by 2, I get 8 over 20. If I multiply 4 over 10 by 3, I get 12 over 30. If I multiply 4 and 10 by 4, I get 16 over 40. Oh, look, we finished the table without needing the rate. Here's where I think the rate is actually helpful, because here's what I'm going to do. I'm going to extend this table just for fun, and I'm going to do 1, 2, and 3. So 1 is actually really nice because it's 2.5. There's like this hidden concept in here that when x equals 1, the y equals the rate. So for us, we know that we already knew. Let me erase that. Guess I didn't have to, but we know that the rate is equal to 2.5. So the idea is that it's 2.5 per whatever unit, right? So it's 2.5 hours per concert. It's $2.50 per slice of pizza, that type of thing. So that's where this is that we can look at this and go, hey, this is $2.50 for 1 slice of pizza. So maybe you could do the math a little easily from here. It's $5 for 2 slices of pizza. It's $7.50 for 3 slices of pizza. It's $10 for 4 slices of pizza. And so that's where this info comes in too, is it's $20 for 8 slices, $30 for 12 slices, $40 for 16 slices. Who's paying that much for pizza? I don't know, but I don't care either. Actually, I think people are, because pizza's not the cheapest thing on earth when you get real good pizza from real good places. No hate to Little Caesars, but actually, yeah, hate to Little Caesars. It's gross. All right, so what I want to do is go down here and graph this thing, because that's what we're supposed to do. We are supposed to finish each table, find each rate, graph each one below, and then write the equations. So let's do that. We finish the table, and if you were to see just my answer sheet, I have a note next to the graphs that says, hey, listen, the graphs they're really the only reason they're tricky is because you overthink the graph. And what I mean by that is, if you look at this, I have 1, 2, 3, and these numbers, and they're actually pretty easy to graph, except the fact that the graph goes 0 to 5, 0 to 5, and I did these, and that already goes off the graph, and all 4 of these are off the graph, so it's like, what the heck am I supposed to do? So here's what I'm gonna do. You could mark it like this. Our x's were 4, 8, 12, 16. You could do that down here. So 4, here, hang on, let me zoom in a little bit more, make my writing a little bit easier to read here. 4, 8, 12, 16, 20. We didn't go up to 20, but we could. And if you're like, we did right here, then that's not the 20 that we went up to, right? These are the x values, right? The y values were 10, 20, 30, 40. So check it out. 10, 20, 30, 40, 50. So we can pretty easily graph this. It was 4, 10. They gave us that. 8, 20. We found that. 12, 30. We found that. 16, 40. That's not that tricky. And now here's the graph, right? So that was on the one that we did without even really having to think that hard. But what about this one? I'd like to show you this one on the same graph for one particular reason. So what am I gonna have to do? I'm gonna have to rewrite my labels. And that's the overthinking tricky part, is the labels, okay? So I'm just gonna call this now 1, 2, 3, 4, 5. And what happens when I had 1, 2, 3, 4? Well, 1, 2, 3, and 4 went all the way up to 10. If we happen to go to a 5th slice of pizza, then that would be $12.50. So let's do it. Let's just go up. $2.50, $5, $7.50, $10, $12.50. So check it out. 1 slice was $2.50. 2 slices was $5. 3 was $7.50. 4 was 10. By the way, this 410 is technically this 410 from the other way. And don't focus on that, by the way. So anyway, the idea is, look, it's the same graph. You could potentially have a different looking graph. What if you had done this? 2, 4, 6, 8, 10. Okay, 1 slice was, what did we say? It was 2.5, right? So that's actually going to be a little bit up off of 2. 2 slices was $5, so that's right there in the middle. 3 slices was $7.50. That's like right there-ish. 4 slices was $10. Do you see how that is off of that line? And this is where I'm like, you could overthink it, because I'm kind of exhibiting 3 different ways we could graph the same information. So don't overthink it, is what I'm trying to say. Number 2. Now, one thing I wanted to establish was right here, multiplying is going to be tricky. Dividing is going to be the way to go. If you didn't believe me before, maybe you'll believe me now. 4/5, 4 over 5 right here, times something equals 1/2. Is that the math you want to be doing? Is you want to try and guess what number goes inside of this box? Or do you want to sit here and go, you know what, this is 4/5 times a number I don't know. I can solve that by dividing. And that's what we did over here. We said 10 over 4. The y over the x. The y over the x. So that's what we've got going over here. The y is over the x right there. And if you're like, I'm not going to remember that, you have some options here. Because you can try dividing 1/2 divided by 4/5, or you could do 4/5 divided by 1/2. You will get different answers, and you will want to check them right here. You want to compare them to this guy right here, okay? So, and if you're also thinking, I can't divide by fractions, yes, you can. You keep the first number. You change to multiplication. That's keep. That's change. And now we flip to 5/4. My pen is hard to read. Let me change the thickness of the pen. 1/2 times 5/4. What does that equal? Well, 1 times 5 is 5. 2 times 4 is 8. The rate is 5/8. Now, if you were thinking, I'm just going to do the other one and I'll figure it out, you're going to land in a world of confusion, because this one ends up being 4/5 times 2 over 1, which is 8/5. That seems awfully like this number, right? And you might think, oh, well, that's good, but now is where we have to go check ourselves. Let's take the 5/8, which I'm telling you is the right answer. If we put that there, what's 4 times 5? It's 20. What is 5 times 8? It's 40. 20 over 40 is equal to 1/2. They are the same. So that's why 5/8, that's why this guy is our rate, okay? So if the rate is 5/4, here's what I'm going to do. I'm going to plug in a 1 here, because that allows me to immediately write down my rate. And here's what I'm going to do. I'm just going to keep going. 1, 2, 3. I just have to double this, and that's 10/8. I just have to triple this, or technically just add 5/8 to this, and I get 15/8. So that table might frighten you. It may look a little ugly, and you would be okay to say that. But let's go down here and graph it. We're just going to do 1, 2, 3, 4, 5, because that's what we did here. 1, 2, 3. Now, we didn't do 4 and 5. We could if we wanted to. But here's what we're going to do. 4/5 is so tiny. 4/5 is between 0 and 1. 4/5 was at 1/2. There's our first point. In fact, I'll write that. This was 4/5, 1/2, which was in our original table. Okay? The next number is 1 and 5/8. 1 is here, right? 5/8 is just like right there. It's not very far from 1/2, right? So hang on, let me erase this guy right here so you don't confuse him with that. In fact, I'm going to draw like a little arrow pointing up to the red, pointing down to the point. The next point was 2 10/8. And if you're like, I don't know what I would do with that, I don't know what 10/8 is, here's all I want you to do. Here is 2. 10/8 is bigger than 1, but smaller than 2. And if you're thinking, I don't know that, 16/8 is 2. 8/8 is 1. So 10/8 is just a little bit bigger than 8 over 8. So here we go. 10/8 is like right here-ish, okay? And then the next one, 3, was at 15/8. Dudes, we just said 16/8 is 2, so 15/8 has got to be really close to 2. You seeing this? So now let's draw this line. It looks like that. And by the way, this is just 1, 2, 3, 4, 5. This was just 1, 2, 3, 4, 5, right? There's the line. Yes, this blue dot was a little off, but who cares? I was trying to be close. Does it make sense? You don't want to overthink it, okay? And now we're reaching the part, only 15 minutes into the video, where I'm going to now do tables 3 and 4. So, table number 3. 5 times some number gives us 1. Well, so I'm going to do 1 divided by 5, which there were people in class today who said that cannot be done. It can be done. 5 goes into 1 0 times, but there's a decimal. How many times does 5 go into 10? 2 times. The rate is 0.2. So check this out. I could fill this in how I did this section right here, where I just kind of double things, and that's fine. So like 10, 2, 15, 3, 20, 4. You could do that. Here's what I'm going to do. I'm going to erase this and continue the table just in a slightly different way. If it will switch to the pen, come on. There we go. Just to show you my thinking, okay? I could switch it to, what if I did 5, 4, 3, 2, hang on, we didn't get 1 on there. 1, well check this out. This is 0.2, and check this out, 0.4, 0.6, 0.8. How am I doing that? Well, our rate was 0.2, so it's just gonna go up 0.2 each time, right? So now, again, let's go down here and graph this. In fact, I'm gonna try and keep this all on the same screen. If we do this section, it'll look like this. I'm gonna make my X's like this. 5, 10, 15, 20. And I'm just gonna do 1, 2, 3, 4. So 5 was 1, 10 was 2, 15 was 3, 20 was 4. There's that line. And if you're going, these all seem very, like, similar looking. Yeah, depending on how you set it up, they could look very similar looking. Now, if I go with what I did here, do this in red, just to kind of be distinct, be different. My X's are, hang on, let me zoom in so to label it 1, 2, 3, 4, 5. What if I did this? What if I said, instead of doing 1, 2, 3, 4, I did, hang on, let me erase that again. What if I did 0.2, 0.4, 0.6, 0.8, and 1? Well, check it out. At 1, it was 0.2. At 2, it was 0.4. At 3, it was 0.6. At 4, it was 0.8. At 5, it was 1. Oh, look, it's the same exact line. It just depends on how you set up your labels. Next, 1/4 times a number is equal to 1/2. Maybe you can get this one. Maybe it's going to surprise you with what it is. What we're going to do is we're going to divide 1/2 by 1/4. 1/2, keep, change, flip. The rate is 4/2, which is 2. 1, 2. The rate is 2 because 1/4 times 2 equals 1/2. You don't believe me? Watch. 1/4 times 2/1. You would get 1 times 2, which is 2. 4 times 1, which is 4. And 1/2 equals 2/4. So here's where this one is so nice. This is just 2, 4, 3, 6. This one's so easy. It's just, it starts on an ugly note and you think, oh gosh, this is going to be terrible. But no, this is the easiest one of all of them. So 1, 2, 1, 2, 2, 4, 3, 6. Oh, okay. Well, it's off the graph, and who cares? Boom. I didn't have to label anything. I just graphed it like normal. That is 1, 2, 3, and 4. But wait, I didn't do the equations. Well, let's talk about the equations, because these all kind of go together in the rate/equation conversation. The equation of all of these is y equals kx, where y and x will not change at all, because the k, that's our rate. So check this out. If the rate on this one was 2.5, check out our equation. Y equals 2.5x. I told you, the y didn't change, the x didn't change. That was the rate, it changed. The rate on this one, what was it? It was, I don't even remember. It was 5/8, which seems so gross. So here's our equation, y equals 5/8x. The rate on this one was 0.2, right? So here's our equation, y equals 0.2x. And then our rate on this one was 2. So our equation is y equals 2x. So here, let me put different colored boxes around these so that if you'd like to, you can see them a little bit more distinctly. There they are. In fact, here, I'll just pause for a second. So if you need to pause, you can pause. Take a look at all this. And now here we go. So down here, you might think, well, dude, there's no table, there's no nothing. This over here is gonna help us. When x is 1, the y part is the rate. Oh look, x is 1. Then the y part is our rate. So we can just simply write 15, and we can write y equals 15x. It is literally that simple. Let's slide over here. There's the x, and it's 1. So then that is our rate. So we just write 5, and we write y equals 5x. And then over here, it's super challenging, except that it's not. Our x is 2. Well, what could we do with this information to get x to be 1? How about we divide by 2? So if you divide this by 2, you get 1. If you divide that by 2, you get 13. The rate will be 13, and the equation is 13x.